Good morning, you guys. Hope all is well. I am posting here the review for your chapters 7 and 9 quiz that is going to be posted and available on Monday and Tuesday of this week. So this review, I'm putting the date of 3/26, is really for tomorrow and Friday's set of block days. I'm going to work through most of these, if not all of them, and either way I'll post the answer key to it on the website. I've already posted the blank review as an assignment, some of you have seen, and then the assessment will open up, like I said, on Monday. Okay, so solve the differential equation. Remember that we are separating, we are integrating, we are solving for y, and sometimes solving for c if the information is given. Okay. You always want to take y prime, set it equal to dy over dx, so that you actually have separable y's and x terms in the y prime. Okay, so I'm going to multiply by dx and divide by y squared. Okay. So it sort of appears that I have a trig inverse, except I have an extra x up top. So I'm thinking that it's not truly a trig inverse. I'm going to try by rewriting this square root to the numerator and see where that takes me. On the left-hand side, I have no issues because I just have a y to the negative second, so that's a power rule. So I can actually integrate that now. Y to the negative second dy, I'll rewrite it first, equals integral of x, 1 minus x squared to the negative 1/2 dx. Okay. So if I call u 1 minus x squared, then du is negative 2x dx. So the only thing I don't want is the negative 2. So that's what I needed, x and the dx. So left-hand side, again, it's just a power rule, would be negative y to the negative 1 equals integral of negative 1/2 u to the negative 1/2 du. So if I add 1, divide by the new, it would become a positive 1/2 power. Dividing by 1/2 is like multiplying by 2. So then I have negative u to the 1/2 power plus c. Okay. Gonna run out of room here. Get a little bit more. Okay, so I can replace the u, and I still need to isolate that y. So I'm gonna have to divide by a negative 1, and I'm gonna have to reciprocate this entire thing. Apply a negative 1 to the other side. So if I do that, I would have y equals the negative of, I'm just going to show this as a whole quantity, negative 1 minus x squared to the 1/2 plus c to the negative first power. You can leave your answer just like that. Again, the whole goal is to isolate the y. We could rewrite it a little bit if we need to, if we want to. That negative that's out in front really only impacts the negative in front of the square root. Okay, but the negative first power would impact the c term and put it to the denominator. So we really have a positive 1 over, you can write it as a square root if you want, 1 minus x squared plus c. the second one is an initial value problem. Here we have information so that we can actually solve for our c value. Okay, so dy over dx equals y e to the x, divide by y equals e to the x dx, integrate, so integral of 1 over y is ln, absolute value of y equals e to the x plus c. Plug in now if you want. Solve for your c now. Exponentiate. That's totally your call. What you want to do next. So if I were to plug in 0 for my x and 1 for my y.
Mom, can you put the TVs into this cup? Because when I opened it,
E to the 0 is just 1. You would say to yourself, e to the, for ln 1, e to the what power gives you 1, and that would be 0. So c equals -1. So y equals, you could keep it as absolute value, or you could change it to plus or minus. If you don't do this on the regular quiz, it would not matter to me, but the AP, it might come up and it might matter. It is e to the x minus 1. Okay. Or there you go. Okay. So the next problem. Use the table of values to estimate the integral from 1 to 2 f of x dx using trapezoidal sum for subintervals. So look out here because a table is given, right? We know in the past every time a table is given, we want to make sure that our change in x is uniform before we go right to the formula. Okay, so in this case, it's not uniform. We jump from 1 to 1.2, and later on we jump from 1.4 to 1.7. So those delta x's are different. So you really just want to think about each trapezoid as its own. So trapezoid 1, 1/2 height, which is your delta x, times the sum of the bases, so both of the y values, plus your second trapezoid, 1/2, 0.2 again, 4.1 plus 4.8, plus your third trapezoid. Here's where we have 1/2, 0.3, 4.8 plus 6.1, and your fourth trapezoid, 1/2, 0.3, 6.1 plus 7.7. Okay, so in the calculator, we put all of this in. I'm going to pull up a calculator on my computer screen so I don't have to keep going back and forth. Okay, so I have 1/2 times the 0.2 times 0.4 plus 4 plus if you notice, just like the formula asks, each of those interior heights are used twice, and the exterior heights at the far left and the far right are only used once. All right, I'm getting an answer of 5.345. Okay, and that's approximately equal to integral from 1 to 2 f of x dx. Okay, so now we have slope fields. So in the first example up top, number 4, slope field is given and original or regular equations are given, right? Not the differentials, not the slopes. So for these types of problems, I like to look at the graph and say, well, what kind of pattern do I see? I don't see a parabola. Maybe I see an x cubed, right? Maybe that would work. I don't see a sine wave because that would be going up and down. I don't see a tan because that should be repeating, right? There should be vertical asymptotes and have multiple branches. And in e to the x, I also don't see because that should be just have a horizontal asymptote at 0. So my best case is an x cubed. So through that, I would be confident in that answer just by looking at the pattern. If I wasn't so sure, remember, you can always derive these. So dy over dx equals 3x squared. So what that is saying is it doesn't matter what your y value is, your slope is all dependent on your x value. And it's growing. It's growing steeper and steeper and steeper in a positive direction as x gets larger, which is why you see we basically have these vertical lines on both the left and the right of the x-axis. And it only flattens out at 0 because that's when x is 0. And it's flat there the whole time. And as we move to 1, assuming the first tick mark is 1, it gets a little bit steeper to a 3. And then it would be, a 12 and so forth. So that also confirms that x cubed would be the equation, 3x squared is the derivative. Okay. Something like number 5, you only have to plot your slopes along the axes and the dots that are provided. So y prime, or dy over dx, or the slope, is equal to the relationship of negative x times a y. So the values are given, so I'm going to start at 0, 0. So of course that would be 0. And if I move right to 1, 0, that would be negative 1 times 0, so I'm still 0. So that means any time either the x or the y is 0, I have a slope of 0, so that helps a lot. So in the first quadrant, I have the ordered pair of 1, 1, so negative 1 times 1, negative 1 slope. Moving to the right, negative 2 times 1, a little bit steeper. Moving up, 1, 2 would be slope of negative 2. And then here we would have a slope of negative 4. Second quadrant. Now, the x is now negative. The y is still positive, which means my slopes are going to be positive. So a negative 1, 1 would be a positive 1. A negative 1, 2 would be a positive 2. A negative 2, 1 would be a positive 2. And a positive 4. Down here, in the third quadrant, both are negative. We have a negative already, so 3 negatives are going to remain negative. So 1, 1 would be negative 1. 2, 1 would be negative 2. Negative 1, negative 2 would be negative 2. And 4, negative 4. Now I have my y is negative, but again I have a negative in the original, so I have 2 negatives or a positive. 1, 2, 2, 4. Okay. Resembles a circle, but I don't have to go any further than that. This is it. Okay, so that's it, guys. I'll post this video. I'll post the worked out solutions also as a PDF.